Deep in space, something strange is stirring. Two black holes collide, sending ripples across the fabric of space-time. But there's a mystery hidden inside that gravitational hum. Is it evidence that black hole mergers may be far more tangled and thrilling than anyone ever imagined? Scientists may have just picked up something totally new, a third black hole hanging out in a black hole collision. Basically, when two black holes smash together, they make a kind of background hum. In one 2019 event, researchers noticed a weird signal inside that hum. It looked like a pair of black holes was speeding up in a way that didn't make sense, unless a third black hole was involved, hovering nearby and messing with things. It might be the first time anyone has found clear proof of a third compact object inside a black hole merger. When two black holes are stuck in a close orbit around each other, it's called binary black holes. Like regular black holes, these systems come in two main flavors, vanilla and chocolate. No, not really. One kind is stellar mass binary black holes. These form when really massive stars pass away in pairs. Ooh, how romantic. Or when two separate black holes end up capturing each other. The other kind is supermassive binary black holes. Scientists think they usually form when two galaxies crash together and merge. We got the first direct proof of stellar mass binary black holes in 2015 when LIGO detected gravitational waves from a massive collision, and it proved that not only do binary black holes exist, but that they also merge. Unfortunately, for supermassive black hole pairs, the evidence so far is indirect. Astronomers have spotted galaxies that look like they have two cores, which could potentially mean that each core has its own black hole. Others look like they might have two black holes hiding inside a single core. Some galactic centers even flash with periodic bursts of light. A giant object could be orbiting a black hole there. But there are also galaxies that show odd motion, which suggests a binary supermassive black hole. For instance, this galaxy has a black hole that seems to be moving in a strange way. It could mean it's part of a merger or a binary system. And then there's a quasar that looks like it has a pair of black holes orbiting each other every 1900 days. Binary black holes appear like this. When two galaxies smash together, their giant black holes in the middle don't usually crash right into each other. Instead, they just fly past on wide curves, unless something slows them down. That something is called dynamical friction. Basically, when a black hole passes near stars, it gives them a little slingshot boost, and in the process, loses some of its own speed. With more and more of these encounters, the black holes slow down enough to get stuck in orbit around each other, forming a binary. At first, this process works pretty well. But as the black holes get closer, they start to clear out the stars and gas in their path. With less material around to slow them further, they eventually stall. In the end, mutual gravitational attraction can make the black holes spiral together, but that only kicks in when they get very close to each other. And so, the big question is, how do they make that last jump? More stars or gas might drift close enough to the pair, and each time a star swings by and gets flung away, it steals a little energy from the orbiting black holes. Another possibility is the influence of dark matter, an invisible and hypothetical form of matter that does not come into contact with light or electromagnetic radiation. And there's one more dramatic option. What if a third supermassive black hole joins the mix? This could actually happen if the galaxy with the pair collides with yet another galaxy. Three black holes together create chaotic orbits, which open up two extra ways for energy loss. They wander through a bigger part of the galaxy, hitting and slowing down on more matter. Or their orbits get stretched into long ovals. And then, when they swing really close to each other, they lose extra energy through gravitational waves. So, has this third option just been confirmed? We'll talk about it a bit later. First, let's check out the life of a binary black hole in detail to understand this process better. The first stage is called the in-spiral. This is when two black holes are slowly circling each other while their orbit shrinks bit by bit. As the two black holes move closer together, they spin around faster and faster. This makes the gravitational waves much stronger. Eventually, they reach what's called the innermost stable circular orbit. It's basically the last safe orbit before they spiral in for good. After that, things speed up. The orbit eventually becomes unstable, and the two black holes plunge toward each other. When they collide and merge into one, gravitational waves hit their peak strength. This is the loudest, most dramatic part of the whole process. Right after the merger, the new black hole is kind of messy. It's stretched, distorted, and not stable yet. It goes through a phase called the ring down. During ring down, the black hole shakes off its uneven shape and settles into a smooth, stable form. While it's doing this, it gives off gravitational waves that mathematically sound like the fading echo of a struck bell. As the ringing fades, the waves get weaker and weaker. It means that the black hole is becoming calm, symmetric, and stable. Since 2015, when scientists first caught gravitational waves, they've logged about 300 black hole smash-ups, all thanks to the ripples, also known as gravitational waves, they've sent through space-time. By studying those ripples, astronomers can figure out how big the black holes are. Sometimes, the data even points to something called hierarchical mergers. That just means black holes merging, and then those new bigger ones merging again, and so on. It's like building up huge black holes step by step. Now, here's why that's important. Black holes born from stars can only be so big. When a giant star reaches the end of its life, it goes supernova. If it's under a particular mass, the outer layers blow off and the core collapses into a black hole. But if it's too massive, the whole thing just blows apart. No black hole left at all, just debris. So, if astronomers ever spot a black hole heavier than a certain limit, it means it probably didn't come straight from a star. Instead, it might have come from earlier mergers. Now, let's get back to the event we started our story with. It didn't break the mass limit. Actually, it was the opposite. One of the black holes was teeny by black hole standards, just 2.6 times the Sun's mass. That's so small, it's right on the edge of maybe not even being a black hole, but a neutron star instead. The other black hole was way bigger, around 23 solar masses. That size mismatch is super weird. Usually, binary black holes are way more equal in size. But here, one was a giant and the other was tiny. A team from the Chinese Academy of Sciences thought this odd pairing might mean something else was at play. They suggested the two black holes were part of a more complicated system, with a third, much larger black hole pulling on them while they orbited around it. To test this, they studied the gravitational wave data. If a pair of black holes is circling a third one, the signal should show a little extra acceleration along our line of sight. The team modeled how that would look and then compared it to the data they had about the event. And their model fit. The data pointed to an acceleration of about 0.0015 times the speed of light, with a 90% confidence level. That's a very strong hint that a third hidden black hole was really there. If that's true, it means black hole crashes aren't always simple two-and-done events. Sometimes they may happen in messier, more complicated setups. And there might be other strange cases hiding in the data, just waiting for someone with the right tools to spot them. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.